excited to introduce our speaker here, Xenia, who is a seasoned cybersecurity professional, currently working as a product manager at Elastic Security, and she has a lot of experience and competence in different fields. One of her specialized fields is threat detection engineering, and that's what she will be talking about today. Please welcome Xenia.
Morning. Good. Test. Can you hear me? Good morning. Good morning. Good morning. Good morning. All right. Morning, everyone. Welcome to. Oh my God, I'm like Sha, MCHY. Welcome to Y 2025. I'm very happy to be here, and I will be talking about detection engineering and why I think right now it's the best time for detection engineering ever. So who am I? My background is in cybersecurity. I studied it. The choice after the school was because it was so exciting and kind of spy. Since then, I worked in many different jobs, did some security operations, forensics, did product management in cyber threat intelligence as well, and now I'm at Elastic, working on the detection engineering experience. I'm from Ukraine, but I moved to Netherlands about 14 years ago right now, so I have 2 homes, and also my journey to security product management was from security and product management, and I'm thinking, like, how do I combine those 2 things, or like, what do I choose? And apparently I could combine it, so yay. I'm not the first time at the Dutch Hacker Camp, so I'm very happy to be returning for the 3rd time, and this is my first time speaking at this event. And at our first event that we attended in 2017, my son was there when he was 3, and he's also joining today with his sister, so I'm very happy that my family is here, and very happy to be among friends and former colleagues as well. All right, so why am I talking about detection engineering? What does Elastic do? Probably a lot of you know about Elastic from the ELK stack and the open source search that I got to touch quite early on, before even using a SIM. Like it's become a global company since being founded in 2012, and not only it does search now, but also has developed observability and security solutions. And in security, this is where I work. Security at Elastic, it's a platform for security analytics and also endpoint security. And I'm very proud that in the past year, we have accomplished this kind of milestones where, like, we were named the leader in Forrester Cyber Security Analytics Platforms Wave, and also our endpoint security is being tested regularly with the AV comparables, and regularly we gain quite high scores there. And the area, why do we score so high, and why do we like get the leadership positions, is because of the work that the teams are doing. And the researchers that I work with, they work on detections for endpoints, and this is why we are getting these high scores. And this is all to add that the Elastic Security was released first in 2019, so it's only like 6 years old, and we are competing with the other platforms that has been there for quite a long time. All right, in my job, I work with our internal development teams that create the features of Elastic Security, and also the threat detection engineers and security researchers that are producing different detection rules that we also open sourced, both the SIM part of the detection rules and the endpoint rules. So if you are interested to see the logic behind different threat detections, they are all available on GitHub, and you can follow the links that I have attached here, or come speak to me and I will point you to some of those. Our threat research, the Elastic Security Labs, often produces reports on different threats, and they do malware analysis. So there is a website that contains a lot of information with deep dives and interesting findings that you can use also for protecting your environments. They also make a global threat report. That is a report that we can see among many different companies that look at the threat landscape and kind of see what is happening around and what trends are there, what is the most common threats that are being detected, how do we see the threat landscape change. I also work with a lot of users of elastic security, and of course my focus is detection engineering, so I really seek to find people who are in that space and to understand what are they building, like what are they, where are they at, and what are the struggles that they have, and how can we help them. So I'm very excited about opportunities to discover like what's the vision for detection engineering and really help people get there. I also work with our internal InfoSec team that protects our elastic corporate assets, and they are using our SIM and our endpoint security to protect elastic, and that's also interesting to see how they approach detection engineering. So yeah, this is who I work with, and this is why I'm talking about this topic. So let's step a little bit back and talk a little bit about detection engineering. It is systematic and operationalized creation and maintenance of relevant detection logic to find incidents in logs. It's quite well defined, and as a detection engineer, the job of the person who is a detection engineer, is to understand the environment that they work in, understand the tools that they have to create detections, what kind of capabilities they have, do threat modeling or collaborate on threat modeling, and find what threats need to be detected and create those detections. And detections artifacts can be a rule, which is basically a search, or anomaly detection, some kind of machine learning job. They would also do emulate those threats, try to make a lab to test them out, and check those detections. I will talk a little bit more about it in a bit. In my view, the detection engineering process starts with planning and prioritization. So that's when you have the understanding of your environment, your threats, and you kind of go, okay, like this is the coverage that we want to have. So these are the threats that we want to be detecting, knowing what kind of capabilities do we have, what kind of controls do we have in place. So like where do we need to mitigate the risks and detect things. And having a backlog of those things and working them one by one, because sometimes you get like kind of ad hoc scenarios where, there is a new threat in the news, let's see what we can do about it, and that's a not sustainable way to go about the detection engineering process. The next step after you get an item from the backlog to work on a specific threat detection, you do a threat research, understand what the threat is, find out how it works, and check what logs are you getting in your systems, in what format, like what do you need to do about the logs as well to detect this threat, and what kind of capabilities should you use to make this detection effective. Then you go to the detection creation, where you basically write the query, and then it goes into, you iterate, making sure that it doesn't produce too many false positives. It goes via peer review, so ideally there is someone else who can look at your query and detection logic, check if it's if it passes like the internal standards. We see a lot of automated testing happening after that stage. So ideally, before your detection goes to production, you have some checks of the how efficient the query is. Does it return the intended results based on the data that you have maybe in the past or some test data? Then you deploy it to production, so it goes into the into your production system. You monitor the detection to see if it satisfies your requirements. Does it work as expected? Does it run efficiently? Does it error out for some reason? Do you still get the logs, or did the logs maybe stop? If something goes wrong with the query, you can you go back to the tuning and go the cycle of editing, peer review, and testing. And if the monitoring shows that the query is no longer relevant, maybe like your threat landscape changed, you will deprecate the query. So this is the process for detection engineering. And one thing that happened is that since maybe like 5 years ago, actually maybe earlier, there was a talk about like we are getting too many detection queries. It's not really sustainable to maintain them that in the way that they used to be maintained. Let's look at the other practices around us. For example, development practices and utilize them for detection engineering as well. So why not automate testing, right? Like you can write specific tests to see if the query is still working. You can automate deployment, and you can version control because you don't know maybe who made the change, for what reason. So now with the concept of detections as code, the idea of treating detections as a code artifact came about, and a lot of organizations are adopting it, and they are looking to achieve higher quality because of the peer review process, more compliance with the change control requirements, faster deployment. That especially is relevant for the MSSPs. And it fits in like from the detection creation to deprecation of the detection engineering process. So in different capacities, you can use detections as code in all of those stages. It will not help in threat research, it will not help with the planning and prioritization, but it will help with the other stages. All right. Nice and clean picture of detection engineering process. It didn't happen in one day. Detection engineering is, let's say, the discipline started evolving around mid-2000s. I guess like from some IDS systems where it was more closed off, and a couple of different concepts impacted and influenced detection engineering in a significant way that I wanted to call out here. So one of them is the cyber kill chain. That started in 2011, and anybody here familiar with the cyber kill chain? Yeah, okay. So the idea is that you have different stages of the attack, and as a defender or a detection engineer, you have the ability to break the attack on different stages of it, and you want to try to detect or prevent the attack happening like at the earliest stage possible. So that kind of made the detection engineers thinking more like in a staged approach and focus their detections on specific attack steps, which made it kind of like more systematic, a different approach to thinking about it. Around 2012, the big data analytics and SIEM platforms evolved, so it allowed people to store much more data and to start collecting data from many different sources. So while previously you could not get like all the logs that actually probably like now it's still debatable, can you get all the logs that you want? Can you store all the data that you need for like whatever retention period you have? But basically, like from that time till now, it's been developing, and you can like get more and more logs. You can get more and more data sources, including your custom ones. So that's been a big shift as well. In like, hey, like we can now detect. Like, what about making detections across different data sources, for example? In 2013, David Bianco introduced pyramid of pain. That is also a very nice concept about what how to say, like what. Indicators or like what things in the attack can the attacker change easily or like have trouble changing, right? So it starts with like hash values, which are trivial to change. For example, if you recompile a file in a different way, change some things, you will get another hash for your binary, and if your detection is working off that hash, that is no longer no longer going to work. So the idea for detection engineering is to not detect this kind of trivial indicators of compromise, but to go higher up the pyramid of pain and detect actually behaviors. So look for more abstract concepts that will not be so easily changed by attackers, and this will prevent your detections from expiring or becoming obsolete in a short time. So yeah, this kind of, again, teaches the detection engineers to shift from, hey, like, I know this should be this IP address or this hash that I need to detect, to like, okay, how can I describe the behavior of this malicious activity in such a way that it will not become obsolete very soon. In 2015, MITRE ATT&CK was introduced. So this picture here, I'm sorry if you cannot read it. I did not realize that was quite small. So the picture here maps the cyber kill chain to MITRE ATT&CK, and MITRE ATT&CK was a framework to map the adversary tactics, techniques, and procedures and describe them. And it created a common language between defenders about like what are we actually detecting, which made it more formalized and kind of more easy to talk about things. MITRE does a great job maintaining it, and looking at all the open research out there to update the MITRE ATT&CK. And it's evolved from like this kind of concept to a very a lot of context around attacks and detections. It provides a lot of information about what are the what groups are using these techniques, what are the examples of attacks, and also like ways to detect, what kind of logs do you need to collect. So it's really good source of information for detection engineers to structure the detections, and it's amazing to see how much it got adopted. I saw it for the first time in 2017 when it was, let's say, promoted to hey, like everybody, you should use this the MITRE ATT&CK because it helps to map things better. Like, so, okay, I have a control, I have a mitigation, I have a detection. Like, what am I actually like? Are they overlapping, basically, right? So it's amazing to see that now everybody is using it, and how the attack is evolving with every half-year releases of a new version. All right, in 2017, the threat hunting was more or less formalized, and the threat hunting discipline talks about basically finding threats in your logs without any like kind of like going on a hunch and trying to find anything bad without maybe having a very clear idea, but just trying to find outliers. Why does it matter for detection engineering? Is because basically once you found a threat that you think should be operationalized, you make it a detection. So the practice of doing threat hunting instead of like maybe going with your preset backlog, it helps you find interesting findings in your data and get more value out of the detections. And around 2019, the detection as code concept was introduced, and since then it also, more and more people are talking about it, and more companies are adopting it. Still, there are challenges. So we know that there is always a new threat, and we get more and more of those basically every week. The attacks are becoming more complex, and the threat actors are more financially motivated. It's very lucrative to go hack around, let's say, and ransomware the companies. There are so many security tools. Not all of them are very well connected, so teams have to deal with different like complicated tooling and with their internal processes. So maybe like not in a lot of cases it helps to do a good job there. What I see with different successful security operation centers and security organizations is that when they think about detections, they're not thinking about like, oh, let's make this one detection. They're thinking about how to create a sustainable system that keeps creating the relevant detections and effective detections. And this is why I want to talk about system thinking. It is something that I find really, really insightful, applying it to different disciplines. So a simple universal systems model looks like this. You have a system that has a goal. It has inputs, it has some process and outputs, and it has feedback. This is super simple. Like, there are different models that are out there with different explanations of like what kind of feedback there can be. Inputs are generally kind of like your resources, so people, time, tools and machines, energy, finances, informations, and materials. And the process would be about problem solving, production, management. Outputs can be very different. It can be desired, undesired, intended, unintended, immediate, or delayed. Yeah, the idea is that the system should have a goal. If we apply this model to the detection engineering, then we get this kind of picture with where your input into your detection engineering system is the strategy of your company and security team, the priorities that you have, what kind of assets does your environment have, what's the threat landscape looking like, what's my coverage vision, and when I say coverage, usually I mean the MITRE ATT&CK coverage, so kind of like what do I need to detect from all of those threats. And available data and tools. So you might want to detect something, but you might not have specific data to do that, actually. In terms of process, you get all the items that we outlined on the detection engineering process. And outputs would be your rules or anomaly detections, your exceptions. So like this detection should not fire on this condition. The coverage state, alerts, of course, and the investigation guides and playbooks. And the feedback into this loop would be the efficacy of your detection's performance and coverage gaps. This system does not work in isolation, so it connects to the earlier, like your instrumentation, your data processes, your data processing and collection, and it feeds into the triage, investigation, and response. So if something breaks on the data side of things, of course, you might not be able to detect things in your detection engineering system. If you produce too many alerts, you affect the triage and investigation and response part. If your alerts are lacking context, it will make it difficult for the analyst to analyze what is actually happening. I'm very excited that there are maturity frameworks that evolved for the detection engineering. So the first one was developed by Kyle Bailey, and it's called Detection Engineering Maturity Metrics. Why do I like it? Because there is work that was done to outline different stages of detection engineering, and if you are starting from scratch, or like maybe not from scratch, but you can build a clear roadmap on how to get to a higher maturity level based on the maturity frameworks. And of course, like every organization has their own kind of flavors and approaches, but with the this approach is kind of tested, and it gets adopted by different companies. So the detection engineering maturity metrics talks about 3 levels of maturity: defined, managed, and optimized. And in defined, you do have detection engineering activities, but they are mostly ad hoc and like reactive. So you heard some news, you make a detection. Your detections are not very high level on the pyramid of pain axis, let's say. They are focused on indicators, and usually there are no dedicated detection engineers, so someone else who has some other job has some time to do some detection engineering. Then it moves to managed state, where you have specific people who are working on detections. There is more strategy and planning, and you identify what kind of logs do you need to track to make sure that those are being logged. And the optimized stage is the highest one, where like you have a lot of automation. You know what you need to that you need to build a very like time. The detections that will last for longer. You are using automation with detections as code, and also going into the anomaly detection too. And this framework has these 4 maturity tracks: people, process, technology, and detections, which is also very nice. With where on the people side, it describes like what kind of at what point do you need to think about specializing your folks in different technologies, what kind of skills you need to build up, and at the most mature cycle, you don't want detection engineers to focus only on detections, but also think about collaborating with those other functions that are affecting your detection engineering practice. In terms of process, again, there's description of different activities that need to be happening, including tracking metrics and having a backlog. And technology is about log sources visibility, getting into detections as code, and the detections themselves, again, like getting higher on the level of the pyramid of pain and providing more context for the analysts. All right, Elastic Security Threat Research has also released the detection engineering behavior maturity model, and this one is a bit different. This one talks specifically about the different processes that you can implement to make your detection practices more mature. There are different levels, and they build up on each other. So starting with foundation, you do start with threat modeling, and you have the roadmap and start a structured rules development process. When you get to a higher maturity level, you add additional processes to this, to the foundation ones, and so on. So you end up with having a full cycle of detection engineering processes, from, like, let's say, easier to implement and the ones that are like more fundamental, to the ones that are more difficult, and like you can get to them once you've nailed down all the previous ones. And it also contains a lot of information on the different metrics that you can track for each of the processes, qualitative, quantitative, and it really zooms out on the process side of things, which is really interesting and helpful, when you're building a practice. I will touch on metrics and measurements. So all of these frameworks also talk about what do you need to track for your detections, quality and efficacy, mean time to detect, mean time to respond, how many alerts are being resolved automatically, what's your coverage, etc. And there are metrics also for the different cadences of the processes. So how often do you do threat modeling? How often do you do external validation of your rules and testing? Why do I want to bring this up? I will mention in a bit. So what do we see now is that detection engineering has evolved best practices. There is a lot of information sharing out there. So like you can find so much information right now on different aspects of detection engineering. We know what processes should be there, what are the success metrics, and we see that more funding is accommodated for the detection engineering functions. So there is a recognition that this function is very important, and it has to be properly staffed, and it has to have focus. More automation, more specialization in people skills development. Let's talk about the elephant behind the tree. I didn't talk about AI so far. I will not talk about what is AI. I'm assuming that a lot of people did hear about it. Let's go on the notion of the promise of AI is that there is this amazing system that you can ask to do something, and it will make whatever you ask it to do, right? And of course, there are we can argue about what is it capable of right now, and where did it deliver, where did it not deliver. I don't want to zoom in on that, but kind of let's explore where it can take us in terms of detection engineering. So in the detection engineering process, where does AI fit? I think everywhere. So it depends on how do you use it. But basically on every step of it, you can use AI in some capacity. And what are the AI application options here? So first one is the AI augmentation. So it's ask an LLM, right? Hey, can you build me a detection for this and that? Okay. It heavily depends on the prompt that you write and what context do you provide to it, right? So if you ask it very generic question, you will get a very subpar quality answer. the augmentation part, it can be, you can go to ChatGPT, ask it to create something for you, or whatever other tool that you're using, or it can be built into the tool that your security tool that you're using. And of course, SOAR, the security orchestration and automation and response tooling that automates a lot of mundane tasks for security professionals is not left out, so you can build any workflow that includes AI using your SOAR. An example, hey, here is, I want you to detect with a specific language something that is common knowledge on the internet, so LLM should know. It can translate very nicely the ask that I have in my human language to the computer language or query language that it knows of. It knows the syntaxes. It has a lot of examples already out there, so that's why it can produce quite a good result, which of course you still need to check and not trust it blindly. But again, going back to our more metrics and automations and testing, this is all doable and possible. So this was the augmentation part. Then we go into the AI agents. These are, why do I like it more than augmentation and asking LLM with the prompt, is because with the agents you provided with more, it is more controlled environment, so you make it less indeterministic. Your LLM, you ask it to do specific tasks, you ask it to make it, or not you, but whoever built the agent, they provided it with the inputs, with the way to treat the prompt from the user, with the way to provide the output, so it's more consistency, it's less volatile in terms of responses that it provides, and you can also build in many processes inside of it to track its own quality. It has varied autonomy, so you can go someone triggers the agent to work, or it goes and does things on its own. It can do some tasks, ideally, and it provides better maintenance and management options. An example would be the detection creation model. If we take it and implement with a different AI prompts, provided like with the context in the input, make sure that we outline what process it should follow, and provide a specific description what it has to output as a result, right? And then we do have the feedback loop with specific testing, making sure that the output is of the quality that we want it to be. An example of this would be a detection rules migration. So when companies want to start using a new SIM, there is usually a problem of having to take all the detection rules that were created in the other language and transfer them to the new system, which uses another language, another syntaxes, but you already have all this information, which is most important one, what are you trying to detect, your like prompt, your your detection logic that is just codified in a different way. So LLM can do it as well, quite well. I think it's quite good in translating things, but it doesn't have to be a very simple agent. So the diagram here shows multiple steps that this process follows through, and the agent here calls like LLM when it needs it. It decides what it needs to do on different steps depending on the provided input, or does it need to get more data, for example. Etc. And then we go into the agentic systems, which is, let's say, the least developed concept right now. There is a lot of thinking about how to even approach it. So you can find a lot of articles online on like, hey, how do we organize the multiple agents working? And one thing that I want to mention was why do we want to use agents is because then every single one of them would be modular, so we can maintain them separately from the other ones. We don't want one system that can be that will break at one stage and we cannot find where exactly it's not working. So for this agentic systems, we can accomplish more complex processes and coordinate tasks, and even have other agents coordinating all of this, right? So let's see, like we can have agent for basically every step of the detection engineering process, and test them each one separately, make them specialized in specific technology that we want to detect, we can train review agent, for example, for like on the data that we have, on the data from the other companies, and upgrade it separately from the whole system. So. And then, like, there are concepts around, like, hey, like, we need a coordination agent that will be dispatching tasks, or maybe we have an exploration agent that will be looking around, or like trying to see what tools get what updates, what kind of new capabilities we can discover, and teach new agents with new stuff. All right, so why does it matter? We have all this best practices, all the knowledge about what the process should be, what kind of KPIs do we have, but it's lagging adoption. So a lot of companies, they try to implement it, but it's not so widely adopted. Like, at least, like, not that many companies are on the highest maturity level. So it is really exciting to see this. Like, we have the blueprint, but we just need to get there, right? And with AI, it's also like this evolving concept, evolving magical thing, probably, we'll see, where we kind of know what we want it to do, right? We want it to actually think like a human eventually. We don't know if it's going to happen. And everybody's trying to get there, right? I see the crossover between these two things. Like, while we know what needs to happen on the detection engineering side, we just need to get there. And then, like, how do we try to go there faster? And that's the idea with the AI also, that it helps speed things up. It helps scale things up better, because, again, like, you can scale agents and their performance, etc. So it has a very great potential on the crossover of these two concepts to get us to a really, really good place in terms of security and detection engineering. And with that, I want to thank you. If you like to connect, please connect. I'm on our community Slack and on LinkedIn, and I also have some stickers if you like. And if you have any questions, you can ask them still, I think.
We still have 10 minutes for questions, and I'm sure you will have a lot of questions after this talk, because it was so informative. Thank you very much, Kenya. If you have a question, you can either line up here behind this microphone, or you can put your hand up and I'll come to you.
Yeah, thanks for the talk. You talked about the feedback loop, about when the rules in production, and that the information can be used for developing new rules. Is there anything that can be improved about that feedback loop, perhaps also with AI or not?
Yes, I think so. So let's say you can. If you're talking about, like, what kind of AI application we can have for the feedback loop, I think it's like, first of all, gathering of those metrics, and maybe like making reports in the human language. So on one hand, you can get the like the data itself, right? But analyzing, like, hey, like, something changed since last week, or like, hey, if we look, it's quite good in summarizing the findings, especially from the data. So I think there is a big potential out there, and using making sure that this feedback gets into, if there is any AI or like produce any AI that gets this kind of input. It's very important that the system then gets more like better quality of results, let's say, right? So we can say, like, hey, make sure that if your detection starts to run slower, you find out why is it so? Like, what did something change? Is your system under too much load, etc., and provide recommendations.
More questions? Well, then I have a question. What makes you passionate about the topic you were talking about?
Okay, that's a very, very good question. Thank you. I think, on one hand, so without detection, we wouldn't have alerts or incidents, and we wouldn't know what to respond to. So I think that's kind of like a heart of security operations in a way, because like it's heart or brain, I don't know. Like it looks into, it provides the work for the other part of security operations, and you are also not focused on your like internal operations, but you're also then looking out to the world and thinking about what is important for me to detect. So it kind of it fascinates me, I would say, like the fact that with detection engineering you can go into, you can specialize so much in many different technologies and also learn the tools that you work, or think about the tools that you need to be able to detect certain things. There is so much potential in like making it better. That's what excites me. Yeah, thank you.
Thank you for. Yeah. Thank you for your talk. Thank you for your talk. In your maturity model, like the big elastic maturity model, I saw not only analyzing false positives, which makes sense. It's like, oh, you made a mistake. Ooh, how do we prevent this? But also analyzing false negatives.
Yes,
how
awesome
are you going
question.
to figure out that
Thank
it
you so
was
much.
a false negative?
Yes, this is super great question. So it is not easy, right? Like we don't know what we don't know. There are a couple of things that like where we could know this. One of them is like your detection stopped working. So if it did, and you ran it again, and you found that there were alerts in the time that it was not working, hey, this is your false negative, right? So how, like, okay, let's think, like, why did it stop working, and what can we do to prevent it? That's one thing. The other one is, of course, the like red team assessments, etc. They are not happening that often. There is probably potential in the like more automation out there, but like this is what would contribute to that false negative. It's not the metric that is easily operationalized, and I think that also like this is one of the areas that we'll see like how it develops. The other area that I'm really fascinated about is the testing of the detections, because it's also one of the things that is not that easy to accomplish. Like you can do like quite easy the syntaxes checks. Okay, like did this rule, was this rule tagged with a specific tag? Okay, fine, right? But does it work? Is it like, does it detect the stuff? That is the area that we like. I see certain tools appearing for that, but I think that we will see more and more development in that specific area in the coming years, because people are going to get more to the higher maturity levels, and there is an ask for this part, right? And it's not easy, because every company has a bit of a different how to say, like it's implemented a bit differently, right? So to make it work for everyone, to make a product that works for everyone, it's not that simple. I haven't seen it like nailed down so far. That is like in a very scalable manner. Go ahead, sorry.
First of all, thanks for the talk. Very informative, and I learned a lot of terms I didn't know existed about the whole detection engineering scheme. My question is regarding the detection as code, because I saw it, at least in the presentation, it was still queries looking at logs from the past. But what would it make detection as code? Because detection as code would, for me, mean analyzing the logs as they come in and comparing different streams.
All right. So the question is, what is detection as code? So it's a concept where you treat your detection logic as the code artifact, right? And sometimes people take it wrong. They think like, oh, I need to write a detection as the, like in the code language, Python or whatever. It's not that. It is more approaching it with a different mindset. Like this is this detection rule is a piece of code, right? Let's make sure that we keep the history of it, we track the changes to it, we like version control it, we automatically test it when we merge it, all these kind of things. So it's more about an approach and the process, not the like I write it in code.
One more question in the area of detections as code. If you're writing a large body of software, sometimes you find, oh, these two modules basically do the same thing, let's merge them. But I don't know how that would work with detections, because I can imagine that they live independently and they get tuned independently and get deprecated independently, but maybe they have overlap. How do you deal with that?
Yes, great question. Thank you very much. I think this is where mapping to MITRE-ATT&CK framework or any framework that you want to use is very important, because then you can find, you cluster your detections. And I think also with the AI and like vector search and stuff, you can codify your detections in a way that where you find similarities more easily. And if you're, again, like a LLM can summarize what does this query do. If you provide it with the queries as an input, ask it to summarize what do they do, and then find the similar ones, it will do it very easily for you. So it is possible to do this kind of things. It should be done with the, some periodic reviews of all your detections, which are also part of the maturity framework. Thank you.
Last question.
First, thank you for your talk. I wanted to know what is the approach of the defenders for predicting the future attack and designing the detection for them. For example, like all of the techniques and tactics that are already in the MITRE-ATT&CK, or the techniques that have been used by the attackers. But like, and I understand that while the attackers comes up with the new techniques, the defenders design the new detection for them. Okay, what could be the approach that defender get ahead of the attackers? Because the thing that I find out is that the defenders are always behind the offensive researchers to design the detection.
I think I don't have a perfect answer for this. I think staying on the like higher levels of pyramid of pain, like thinking about the behaviors, that will help, because you it depends on the type of the new, like what type of new attack there is. I think anomaly detection is also interesting in that case, where it threat modeling and understanding your environment also helps, because you can think about the attack paths where the attacker might go from this stage. So you would kind of know like where you maybe have like less visibility, or what kind of thing can happen. I'm not sure if like it is. I mean, of course, it's not probably completely possible to detect everything, right? So you have to be using the advantage of the defenders, which is knowledge of your environment and understanding of your controls, right? So that's the only way I see right now. Thank you all. Enjoy your day. Enjoy. Why?